Well, friends, today we will discuss about the procedures for proximate and ultimate analysis of coal in thermal power plants. Generally, the ultimate analysis of coal is required for the calculation of some of the losses in the power plants, so that we can actually correlate them with the GCV. Then other thing is we may be required it for the some payments to the authorities from where we are purchasing the coal. So for that purpose also it may be required. So in this session today we will discuss about the procedures for proximate and ultimate analysis in thermal power plants. We have the laboratories in the power plants, and there we can take the samples there in the laboratories and determine the proximate analysis. So first of all we do the proximate analysis on air dry basis in the laboratory. So how we determine first of all the moisture in coal on air dry basis. We give the name as MAD, moisture air dry basis. So about 1 gram of finely powdered coal, air dried coal. So it is finely powdered means passing through 60 microns air dried coal sample. It is weighed in a silica crucible and then it is placed inside an electronic hot air oven maintained at 108 plus minus 2 degrees centigrade. Now the crucible with the coal sample is allowed to remain in the oven for 1.5 hours and then taken out with a pair of tongs and cooled in desiccators for about 15 minutes, and then again it is weighed. The loss in weight is reported as moisture on air dry basis. So the moisture in coal air dry basis MAD, this is calculated as 100 into Y minus Z divided by Y minus X, where X is the weight of cubicle in grams, Y is the weight of coal plus crucible in grams before heating, and Z is the weight of coal plus crucible in grams after heating. The typical sample which was collected and the value of moisture in coal on air dry basis was calculated, and it was found to be around 8.43%. Second is the determination of volatile matter, VM, volatile matter content. This is VM air dry basis. So about 1 gram of finely powdered and air dried coal sample is weighed in a VM cubic crucible and then placed inside a muffle furnace maintained at 925 degrees centigrade. But you must take precaution that the crucible must be covered with its lid when it is placed in the muffle furnace. The heating is carried out for approximately 7 minutes, after which the crucible is removed, cooled in air and then in desiccators and then weighed again. So the volatile matter content is given by, on air dry basis, it is given by 100 into Y minus Z divided by Y minus X. So here X is the weight of crucible in grams, Y is the weight of coal plus crucible in grams, that is the weight of SAM, and Z is the weight of coal plus crucible in grams after heating. So the typical value for a sample which was collected and VM was measured, so percentage VM air dry basis was found to be around 19.11%. The third thing is the determination of ash content on air dry basis. So about 1 gram of finely powdered, that is 60 microns air dried coal sample is weighed and taken in an empty silica crucible. Before that, the crucibles must be heated at 800 degrees centigrade for about 1 hour to remove any foreign particles in the cubicle. In the crucible, the crucible along with sample shall be put in a muffle furnace at 450 degrees centigrade for about 30 minutes. After that, the temperature of the furnace is raised to 850 degrees centigrade and the sample is heated for about 1 hour at that temperature. So the ash content, ash air dry, the calculation is done as per the following formula. Percentage ash air dry, this is equal to 100 into Z minus X divided by Y minus X, where X is the weight of crucible, Y is the weight of coal plus crucible in grams before heating, and Z is the weight of coal plus crucible in grams after heating. Typical value for a collected sample percentage of ash air dry basis was found to be 42.61%. Next is the sulfur content in air dry basis. Usually sulfur percentage is taken as 1%, or it is found out from a certain other laboratories where it can be found out, where it can be measured. So sulfur content in air dry basis is taken as 1% constant. Then next comes the determination of fixed carbon. The fixed carbon is determined on fixed carbon air dry basis is determined on 100 and negating all the other percentage from 100, and that comes to around 28.85 from a typical values for a particular sample. Then comes the proximate analysis as received basis. The total moisture, we should know the terms of the total moisture. Tm is the sum of surface moisture, it is the same, and inherent moisture, or MAD, air dry. Moisture air dry, inherent moisture is moisture air dry. The sample which is ground to 60 microns is weighed and then put in open for more than 24 hours for drying. The weight after drying is taken and the loss of weight is reported as surface moisture in percentage. Then the total moisture is equal to surface moisture plus moisture air dry. Conversion of proximate analysis on air dry basis to proximate analysis on as received basis. The K factor is determined as per the formula 100 minus total moisture divided by 100 minus moisture air dry. That gives you the K factor. Then the fixed carbon Fc on as received basis, that is FCAR, will be equal to FC air dry basis multiplied by the K factor. Similarly, volatile matter Vm on as received basis is given by Vm as received basis will be equal to Vm air dry multiplied by K factor, and ash on as received basis will be equal to ash air dry multiplied by the K factor. The ultimate analysis from proximate analysis. For some coals, it is recommended to use Seller and Dulong formula for estimation of carbon and hydrogen, and modified Gebhardt formula for estimation of N for proximate analysis. So it is suggested to get proximate and ultimate analysis of few coal samples done to validate the formulae being used. The proximate analysis of coal is used to estimate the as fired percentage of carbon and hydrogen using Parr's formula and nitrogen using Gebhardt's formula. The ultimate carbon, or the ultimate C, is equal to the formula that is given here, and where Z is equal to total moisture as fired into 100 plus 110 into ash as fired plus 10 into sulfur. So this values of QP, VP and CP, these are calculated, put in the formula, and then for a particular sample, if the fixed carbon is 23.5, VM is 22.2, total moisture is 10.6, and ash is 43.7%, sulfur is 0.4%, then the ultimate carbon value calculated from the above formula comes out to be 34.9. This is using the parse formula. Then the ultimate hydrogen is calculated with the formula that is detailed in the slide. Similarly here also the Z, QP, VP, CP and HP, they are calculated, and accordingly they put in the equation. You get the ultimate hydrogen as 2.7%. This is also using parse formula. For calculation of nitrogen, we use Gebert's formula, and this ultimate nitrogen is given by 2.10 minus 1.2 into Vm as fired. So this, putting the values, the ultimate nitrogen comes to be around 1.8%. The ultimate oxygen is calculated after deducting all the other parameters, all the other contents from 100. So the ultimate oxygen value comes out to be 5.9%. So thanks for watching. Like and subscribe Total Output Power Solutions.